Good afternoon, ladies and gentlemen. Welcome to the International Conference of Fundamental and Applied Sciences, Icfas 2020. This is Parallel Session 2, Room 1. I am Dr. Chong Fai Kiet, your chairperson for this session. After every presentation, there will be a 5-minute Q&A session. The first presenter, let us welcome her, Dr. Liazat Bekbayeva. She is from Isfandiyarov, Kazakh National Medical University, Department of Engineering Disciplines, Kazakhstan. Let us welcome her with her title, Effects of NPK Fertilizers on the Growth, Yield, and Chemical Content of Tomato. Lycopersicon esculentum L. Mill. Dr. Liazat.
Assalamualaikum. I am Liazat Bekbayeva from Kazakhstan. I am staff at the Department of Biochemistry at Kazakh National Medical University in Almaty. Today I would like to say thank to all the organizers. I hope that everything is okay with you and with your family. Today I would like to start my presentation. Title is Effects of NPK Fertilizers on the Growth, Yield and Chemical Content of Tomato. Outline of this presentation is introduction, then problem statement, research objectives, materials and methods, results, discussion, and conclusion. Tomato is the most important vegetable grown in the world, and the demand for the fresh fruit is continuously increasing. Tomato is widely consumed in many traditional dishes and as non-leafy vegetable and used in the preparation of stews, soups, salads, ketchup, sauces, and juices. Also, tomato is a heavy feeder of plant nutrients, including nitrogen, phosphorus, and potassium, and requires micronutrients for growth and development. Growing tomato is not an easy task since the plant is exposed to many constraints, while the fruit itself has to meet certain market requirements. So numerous authors have studied the effects of different fertilizers and manures, nutrients on the yield and the quality of tomato, and it becomes clear that some of these nutrients play a key role in tomato production. As problem statement, increasing human population has resulted in increasing pressure on land and soil resources due to increase in cultivation of crops to meet the ever-growing food demand, lead to depletion of soil fertility. Soils in Malaysia are constrained by low acidity, inherently low infertility, and require external inputs to improve their fertility, leads to the decrease of the agricultural production of most crops and affects soil physiochemical properties of the area. Malaysia in general has a humid tropical climate. The rate of weathering is high. The use of fertilizers and manures are the most effective and convenient way to improve soil fertility in Malaysia. To solve this problem statement by using novel fertilizer based on NPK fertilizer. The main objective of the study was to assess the effect of NPK fertilizers on the productivity of tomato plants. The specific objectives of the study are as follows. To establish the effects of NPK fertilizers on the growth and the productivity of tomato plants, to determine and compare the optimum level of the NPK fertilizers and obtaining superior vegetative and reproductive characteristics, both quantitatively and qualitatively. So to investigate the chemical content of the leaves and fruit of tomato under the treatment of the NPK fertilizers. Materials and methods. NPK fertilizers were prepared by mixing 90% Pu35, Pu50, and the Pu65 with 10% potassium persulfate. Pu means polyvinyl alcohol with urea. So in NPK fertilizers were used with constant concentration, 1% water per volume using distilled water. So in table 1, you can see the elemental composition of NPK fertilizer. Elements, the different concentration of NPK shown here. So NPK 35, NPK 15, NPK 65. Here carbon, nitrogen, oxygen, phosphorus, potassium. After that, we tested different types of tests as determination of vegetative growth, as plant height, number of lateral branches of the main stem, and number of leaves per plant, leaf area, fresh weight of shoots, dry weight of shoots. Also, determination of leaf composition included pigments, carbohydrates, nitrogen, phosphorus, and potassium. After that, we determine of flowering characteristics, not number bearing for the first flower, number of flowers clusters per plant, number of flowers per cluster, number of flowers per plant. After that, determination of fruiting characteristics are a yield number of fruits per plant, mature fruit weight, mature fruit shape index, mature fruit volume. And the last test was determine chemical composition of the tomato fruits, soluble solid content, titratable acidity, ascorbic acid content, and lycopene content. So as a result, effect of NPK on tomato vegetative growth. So, the effect of NPK fertilizers treatment with various concentrations of NPK on tomato plant head is shown in figure 1. The results indicated that the NPK fertilizers has had a positive effect on the plant head compared than control. An increase in nitrogen content from 7.8% in NPK 35 and to 31.7% at NPK 50. So resulted in increased plant height at 4 and 8 weeks. Also, increased nitrogen content from 31.7 means NPK 50 to 40.3% means NPK 65 caused a reduction in plant height at 4 and 8 weeks. So here, all treatments of the NPK fertilizers had a significant effect on the fresh and the dry weight of shoots. So that the control plants at 4 and the 8 weeks at the figure 2. Also, figure 3, here you can see the high chlorophyll content of the plant. The highest chlorophyll and A and B recorded in plants fertilized with NPK 50. For carbohydrates in figure 4, you can see the effect of NPK fertilizers on carbohydrate in leaves of tomato plant. So here is similar. NPK 50 gives us the highest results. Characteristics of flowers. Number of flowers per tomato plant, you can see the similar results. Here NPK 50 concentration higher than other concentrations and including control. Also next figure 6 about number of fruits. So number of fruits, the NPK 35, NPK 15, NPK 65 gives us is good results then compare if we compare it with control. Also, next slide about chemical composition of food. So effect of NPK fertilizers on soluble solid content and the titratable acidity on tomato food. Also, NPK fertilizer on ascorbic acid and lycopene in tomato foods. As discussion, so here on the picture, the structure of polymer blend. This is new material exhibiting combinations of properties that cannot be obtained by individual polymers. So our NPK fertilizer PU contains nitrogen, which it delivers to plant roots when used as a fertilizer. Also, PU contains the optimal level of nitrogen, 50%. Pews promoting the leaching out the salt from the soil because PBA is aggregated with soil. Also, Pew react with metals in the soil and from long cross-linked polymers in the soil and improves soil texture. As conclusion, I can say that NPK fertilizers treatments were carried with the aim of improving tomato growth and yield and the leaf chemical composition. Also, NPK fertilizers based on mixing 90% pure fertilizer with 10% potassium persulfate with different nitrogen content as NPK 35, NPK 50, and NPK 65. Data on plant height, number of lateral branches, number of leaves per plant, leaf area, fresh and dry weights of shoots, chlorophylls A and B, carbohydrate content, nutrient content, node number bearing the first flower, number of flower clusters per plant, number of flowers per cluster, numbers of fruit, weight, volume and shape, index of fruits, soluble solid content, acidity, vitamin C, and the lycopene pigment were recorded and statistically analyzed to evaluate the treatment effects. So results revealed that growth in tomato was more highly influenced by NPK treatments. However, the highest vegetative growth, food yield, nutrient content, in the food content were found in tomato plants fertilizer with NPK 50, followed by NPK 35 and NPK 65. So this is next slide is about next trial test for mixed fertilizers in greenhouse Kazakhstan after Malaysia. So we got good results in real tomato plants. Also, and one newspaper in Kazakhstan write about our research work. Okay, thank you very much. Terima kasih. Hello.
Hello,
Assalamualaikum. How are you?
how are you? Nice to meet
I'm
you,
glad.
Dr. Liazat.
Nice to meet you. Nice to meet you too.
Thank you for the presentation. Are you
Thank you
ready
for you
to have
too.
some questions?
Yes, I'm ready. Please, if you have
Okay.
question.
Okay. Looking at the content of the nitrogen, based on the
Yes.
recipes that you have, there are three different content of nitrogen. It seems that the trends are the same whether uh, uh, it is based on the number of flowers or number of leaves, the area of the leaves, and so on. The trends are very
Yes.
consistent. Let's say if I were to conduct the same kind of research, and I find that based on the chemical characteristics for the tomato fruits, there seems to be whether I need to choose which is more important, vitamin C or lycopene. What do you advise? Which
Mhm.
property do
Uh,
you think is
mm,
more important?
Usually, lycopene is more important for definitely for tomato fruit. So, mhm.
Lycopene is so important because it is also a very
Yeah.
important ingredient for anti-cancer and so on, right?
Yes. Yes.
Okay,
Anti-cancer ingredient also.
understood.
Mhm.
And there's another question.
Yes.
The different phases of growth. The first stage where it is growing up, and flowering stage and also the fruiting stage. Do you think
Yes.
that at these different stages, those plants will require different composition of NPK?
Yes, because in different stages we change the content of NPK. Also, we changes because just I took from all results only 8 weeks and 14 weeks. Usually, in every stage, we have to change the NPK concentrations. If in the first stage we give a little bit more N nitrogen, but little bit when after get flowering before fruiting we will add more potassium.
I see.
So we have to change every stage.
Okay.
Um,
I guess that's all the questions directed to you, Dr. Liazat. Thank you very
okay.
much for your enlightening presentation.
Thank you very much. Terima
Nice to meet.
kasih. Nice to meet you too. Also,
Yes, yes.
thank you very much.
Thank you. Thank you. Um, so the next presenter, I will call upon Dr. Nazriza Wati Ahmad Tajuddin. She is from the School of Chemistry and Environment, Faculty of Applied Sciences, University Technology Mara UITM Shah Alam. So I'll call upon her to present her title, Production of Green Biodiesel from a Low-Cost Calcium Oxide Catalyst from Waste Freshwater Shells. To you, Dr. Nazriza Wati.
Assalamualaikum and good day. Right, today I will talk about production of greener biodiesel from a low-cost calcium oxide catalyst of waste freshwater shell. In this study, a low-cost environmental-friendly catalyst from freshwater shell of polymer soda erosa, which is Icfas Ps2 which is Lala, and Pholas orientalis, which is Mentarang, are used in the production of biodiesel. Nowadays, the finding of unalternative energy source is a main concern due to the fact that the increment of energy, depletion of fossil fuel resources, expensive price of diesel fuel, global warming, and also due to the environmental pollution. In concomitant with the rapidly increasing world population, the energy demand is predicted to increase by 50% in the present of 2040. Biodiesel is frequently generated in the present of catalyst through method of transesterification, with the presence of alcohol. But somehow, there are so many issues related to biodiesel. First is due to the feedstock. The edible feedstock has increased the biodiesel price. And also, the global issues of oil depletions, which is require a non-renewable energy source. Environmental and health problem also has affected on biodiesel. It being said that air population is generated by combustion of fossil fuel tremendously due to the combustion of fossil fuel. Then nowadays the trend has been shifted to waste cooking oil (WCO) feedstocks to be used as biodiesel. It has been reported that the catalyst synthesized from freshwater shell fits as an alternative renewable energy source. Many studies has been conducted on the growth of heterogeneous catalysts from waste in the uses of shell, bone, and also skins of the marine animals due to their rich of calcium carbonate to be decomposed into calcium oxide during the process of calcination. Waste shell are mainly composed of calcium carbonate, but when it was being heated to higher temperature, for example from 700 to 1800 or up to 900, it will converted to calcium oxide. It also has been reported that calcium oxide derived from a calcined polymer soda erosa, Icfas Ps2 Lala, and also Pholas orientalis Mentarang has potential to be used as a novel heterogeneous catalyst. To date, no extension study has been done using this type of species with the waste cooking oil. Hence, this study is aimed to prepare the mixed oxide catalyst using freshwater shell of Paratapis textilis, Lala, Polymisoda erosa, Kepai, and also Polas orientalis, mentarang as a catalyst before being applied in waste cooking oil for transesterification reaction. The material has been prepared from the waste freshwater seashell. The waste freshwater shell were collected from household waste at Sungai Besar, Selangor, Malaysia. The collected sample of waste freshwater were cleaned and washed for several times with the distilled water. And then it be dried in the oven at 100 degrees for 4 hours to remove the water and were crushed in a small fine powder before it has been stored in desiccator. For catalyst characterization, catalysts were characterized by SRD and also being followed up by specific area and pore size and so pore volume distribution to determine the surface area of the sample using BET, Brownian and Taylor, and then it has been also the surface morphology has been characterized by using scanning electron microscopy (SEM). The infrared spectroscopy has been detect the functional group of the compound, right? And then we also have used DGA and DTA DSE to know the decomposed temperature of the catalyst. Pre-treatment of WC also have been done, where at first to remove the debris and unwanted impurities content, sample has been dried, has been filtered, and then has been dried at 100 degrees for 1 hour. And last but not least, to determine the free fatty acid, 1 gram of the oil is dissolved in 25 ml of ethanol and 25 ml of diethyl ether with few drops of polyethylene, where it being added as indicator. Then titration has been done to determine the percentage of FF. The good FFA content is when the percentage is less than 1%. Process of transesterification has been done where the catalyst, WO and the methanol were mixed for 12 hours at 65 degrees and the sample was separated in separating funnel. The crude oil has been injected into GC where the GC has been set up according to this setting. For results and discussion, in XRD, Figure 1 depicts the SRD of fresh and calcined shell of the samples, and it has been compared with the Joint Committee of Powder Diffraction Standard, DCPDS. The peak appear around 32, 37, 54 are reflected to calcium oxide, 18.22, 47, 50, 54, and 64 are correspondent to the calcium carbonates. Narrow, sharp, and high intent peak of calcine catalyst define the well-crystallized structure of calcium oxide catalyst. However, the calcium carbonate still remaining after calcination at 900 degrees for 3 hours. This finding further confirmed that at high temperature, most of calcium carbonate compound has been completed, transformed into calcium oxide by evolving the CO2. But somehow, some of them are still unchanged and remain. This result is similar to the study that has been done by previous researcher and also their co-worker, where they found that peak calcium carbonate disappears simultaneously with the increment of calcium oxide peaks. Hence, to ensure all the carbonate fully decomposed, higher calcination need to be done. Then next, the surface area of fresh water and shell were further investigated by using nitrogen adsorption-desorption technique. It found to be the catalyst exhibit type 4 isotherm and with H1 hysteresis loop indicate the microporous mesoporous material. It's also associated with a solid consisting of nearly cylindrical character. Okay, and then BET found the surface area was 351 per meter gram. And for SEM, the morphology of calcine catalysts were examined by SEM. This figure shows the surface morphology observed under 1000 magnification. The shell calcine at 900 shows a decrease of agglomeration size and segregation of particle, particularly due to the large amount of CO2 that has been escaped from the decomposition of carbonate, Ca carbonate. Last but not least is TGA. TGA confirmed that it has a high temperature of 800 towards 900. And FDIR found the most dominant characteristic band are dominated by OH, CH, and double bond CH. Okay, at that designated area. So we would like to thank Research Management Center, RMC, University Technology Mara for funding the project. Thank you so much.
Thank you very much, Dr. Nazrizawati, for your presentation. This is a Q&A session now.
Okay.
Any question from the floor? I have one question for you, Dr. Nazrizawati. The reference that you used for the FAME, what is the reference that you used for the FAME? The reference?
We use ASTA standard.
Oh, okay. The ASTM standard. Of the,
Yes.
what is the chain length roughly? The chain length?
Sorry?
What is
Chain
the chain length?
18.
C18. Thank
Yes.
you very much. Okay. I understand that you have used Kepa, what else? Lala and Mentarang. And out of all these, the best performance was displayed by Kepa with its total surface area of 351 meters squared per gram.
Yes, correct.
How far the difference in terms of their surface area comparing with Lala and Mentarang?
Those others are not really well. Okay, they shows lesser than that. All right. So that's why if you see that the yield itself is reflected to the surface area that we have in the material itself. So because it aid the process of transesterification. So it's aid the process of where it's allow what we call fast good process of transformation of oil into the biodiesel itself, okay, because of the surface area itself. In terms of the other species, which is Mentarang and also Lala, it doesn't show any called a strong surface area compared to Kepa just now.
Okay, thank you. I guess one last question. Looking at the XRD for the comparing the calcined and uncalcined the shells, it seems that the intensity reduced drastically for those calcined shells. Can you explain what is the main reason behind that? Although I'm sure you are looking for calcium oxide, but even calcium oxide intensity, the peak intensity decreased too after calcination. Is there any reason for that?
Okay, first and foremost is because of process decarboxylation, the hydroxylation of H2O. Sorry, excuse me. So process of decarboxylation where the carbonate itself has been removed, okay, CO2 has been removed from the surface. That's why the peak area is been diminished. Okay, so that's why you can see that the peaks is collapsed as well. Okay, so that's when it shows that we have another peak appear, which is calcium oxide. So the calcium oxide is the main element that we want in our catalyst in order to aid the process of esterification. Okay, process of decomposition by itself have eliminated the carbonate itself, so that's why the intensity peak is FUC is very dropped compared to the previous one without the calcination.
Yeah. Okay. I guess that's all from the questions directed to you, Dr. Nazrizawati. Thank you for the interesting discussion with you. Thank you very
Thank you so much.
Yeah.
Bye.
Thank you. Bye. We call upon our next presenter, Dr. Noor Ain A. Rahman, and she is currently a postdoc at the High Performance Cloud Computing UTP. Previously was a research scientist at the Center for Research in Iron Liquids for 2 years. Her topic of discussion will be modified alginate adsorbent using ionic liquid for manganese removal from aqueous solution. The floor is yours, Dr. Noain.
Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So now it's my turn for the presentation to share one of our research work. So I'm the corresponding author for this paper. I'm Nurain Abdul Rahman and the other authors are Miss Gauri Sivaraj and Dr. Cecilia. We are from University Technology Petronas. So basically this is our paper. The title of the presentation is Modified Alginate Absorbent Using Ionic Liquid for Manganese Removal from Aqueous Solution. Basically our work is related to the usage of ionic liquid to extract manganese metal. Okay, as I mentioned just now, our intention is to extract the heavy metal, which is particularly in this paper is manganese. So manganese is normally contribute to the rusty taste and reddish color to the water. And at the moment, there are several approach, namely ion exchange, water softening, absorption by natural low-cost absorbent, liquid extraction, and so on have been used. And however, absorption, especially by low-cost material, has become one of the most alternative treatment to extract the metal. Okay, speaking about the low-cost material, alginate is one of the most abundant, cheapest, and environmentally friendly natural material as absorbent. Unfortunately, unmodified alginate is too soft, fragile, and brittle for harsh service environment. Furthermore, alginate itself exhibits poor metal absorption. So what we did in our work is we try to use ionic liquid formulation together with the alginate. So recent advance and development in ionic liquids have helped to broaden its potential in various applications, so including the metal extraction. However, most of the studies shows that hydrophobic ionic liquid is generally favorable for metal extraction due to their ability to extract metal ions in aqueous phase. So the combination or the formulation of alginate with ionic liquid will give several advantages. Number one, it's economically friendly because we are going to use less quantity of ionic liquid in the formulation. Number two, environmental friendly because avoid the loss of the ionic liquid in the aqueous phase. And number three is the synergistic effect from both material, which is ionic liquid and alginates, can enhance the extraction efficiency. So next we move to the material and method section. So this is the reaction scheme of the ionic liquid that I was synthesized. The name of ionic liquid is 1-hexyl 3-propionitrile imidazolium chloride. There will be two stages to prepare the ionic liquid. The first stages is to prepare the precursor, which is hexyl imidazolium, and then the precursor will stir with 3-chloropropionitrile chloride for 48 hours at 55 degrees C to get the ionic liquid. And yeah. Okay, now is the preparation of the formulation of alginate with the ionic liquid. Okay, firstly, alginate and PVA. PVA is the polyvinyl alcohol, will dissolve in millipore water and stir at 80 degrees C for 8 hours. And before ionic liquid was introduced to this mixture. Okay, so we use PVA or polyvinyl alcohol purposely to increase the physical strength of the beads, which is our end product. So once the mixture, which is alginate, PVA, and also ionic liquid, is homogeneously blend together, and then this mixture extruded into a gently stir 3% of calcium chloride boric acid solution using a shrink which give spherical hydrogel beads. So the white bits is actually the product of this process, the end product of this process. And after 24 hours, the bits were washed with water to remove any impurities before they were dried in oven at 35 degrees C for 48 hours. Okay, in this work, RSM or research response surface method were used to study the influence of the variable of these three variables, which is contact time, weight of the bits used, and also the pH of the solution or our industrial effluent or the wastewater, the pH of the wastewater that we use. So these are the three variables that we use, and I decide the range of the level for each level, which is low level, central point level, and high level. So every level we decided the value. Okay. Then the model will produce an experimental arrangement for each variable and propose the optimum size of the experiment. So from there we can propose actually which variable is more significant and contribute to the absorption capacity at the end of the experiment. Okay, this is the flow of the batch absorption experiment. Basically, we use wastewater. We collect the wastewater from one of our near factory over here in Batu Gajah. So the wastewater actually was diluted to 1000 dilution factor by using milk pour water, and based on the experimental design by the RSM, okay, 10 ml of the wastewater actually will be shaken together at 400 RPM for a range of contact time, and the experiment will duplicate to have the result which given as average. And the concentration of metal solution after absorption test were measured using atomic absorption spectroscopy or AAS. So by knowing the initial concentration of manganese, and the final concentration of the manganese by using AAS, okay, then we can calculate the extraction efficiency by using equation 1. This is the NMR result for the our ionic liquid, okay, 1 hexyl imidazolium 3 propionitrile chloride. So the NMR spectra shows the peaks of propionitrile protons coming the linkage to the imidazolium cation at 3.07 and 4.2 ppm. Okay, this is the appearance of the modified bits. Actually the image of the image of our bits are taken by SEM, scanning electron microscope, at different magnification because we want to see the tabulation of the pore on the bits. So we found that the pore size between 155 nanometer to 250 nanometer are tabulated almost homogeneously on the surface of the bits. And the final bits actually, the diameter of the final bits is around 1.22 millimeter. Okay, this is the output from the RSM. Okay, the contour plot shows a three-dimensional response surface plot to, okay, the contour plot is just to show the effect of weight of bits, okay, the first variable. The second variable is the contact time of the bit with the wastewater. And the last variable is the pH of the wastewater. So basically the contour plot shows the highest extraction efficiency of two variables. Like for example, number one, okay, the graph number one, graph A, showing the weight and the highest weight and also the time, the contact time, where the pH of the wastewater at pH 5 and so on. Okay. So from the statistical analysis, okay, as we can see here in a graph here, predicted versus actual, okay, it can be concluded that the optimum values of the variable where it fit the quadratic model at pH 3.4 0.54 and contact time at 225 minutes, and the weight is 0.49 gram with desirability up to 1 at the highest efficiency, which is we get around 95.95%. And the linear plot over here shows the relation of the actual versus predicted value of extraction efficiency of manganese for wastewater, and the R squared for this predicted versus actual value for the model is quite good, which is 0.995. Lastly is to identify the isotope model for this extraction experiment. The absorption capacity for Langmuir and Friendrich model were calculated. So basically the R squared for Langmuir model is higher than the R squared for Friendrich model, which is it gave 0.912. But the Friendrich model we only got 0.771 value for the R squared value. So referring to this R squared value obtained by the regression method, okay, it shows that the Langmuir models describe the absorption of manganese onto the beads is better than Friendrich. Okay. According to this model also, the maximal absorption capacity increased between 14 to 44 ppm of initial concentration, and it was generally attributed to the change with initial concentration, as you can see from the figure here. Okay, these are the conclusions that we can draw from this presentation. Number one, the addition of PVA in this sorbent preparation have enhanced the physical strength of the beads, especially during the extraction process. Number two, the absorption material is easy to handle during or after absorption process and capable to serve an efficient absorption of manganese ions, but still depending on the weight of the beads and concentration, and also the pH of the wastewater during the extraction process. The absorption capacity was found to be initial concentration dependent between 0.5 to 0.25%. And lastly, the last one is the Langmuir acetone can be correlated to experimental data better than Friendrich model. These are the references that are used for this presentation. That will be end of my presentation. Thank you very much.
Thank you very much. Thank you very much, Dr. Noor Ain. I would like to know, based on this work that you have completed, the wastewater source, besides manganese, what other pollutants are also present? Sorry. I cannot hear. Dr. Noor Ain, I cannot hear. Still cannot hear.
Hello?
Yeah, better.
Okay.
Yes.
During the experiment, we just want to know the concentration of manganese. So by using AAS, because AAS only can, like, we have to determine what kind of metal that we want to detect from the wastewater. So that's why we just test for manganese only.
The next question is during synthesis of your material, potassium hydroxide has been added. May I know the role of potassium hydroxide?
Potassium hydroxide.
During synthesis.
During the synthesis alginate and ionic liquid, right? Sodium alginate, calcium chloride.
Potassium hydroxide.
I think that
Maybe
one
control the
for
pH.
yeah, I think that one for controlling the pH. It's nothing to do with the synthesis of our product.
I see. And like one last question here. You have based on your optimization, pH 3.54 is the best, providing you the best capacity of your material. But when you conduct the adsorption isotherm, Langmuir and Friedrich, the pH conducted was 6 to 7. Is there any possibility that you would adjust the pH to 3.54 based on the results from the optimization studies?
Because the optimization, the result given by the optimization is, I think that one from RSM.
Mm-mm.
So it gives that kind of result.
Mm-mm.
But in the end, when we try to fit it with the model, we have another we have another story on that.
Yeah, because the
Mm.
wastewater, yeah. If
Mm.
model it is
Ha.
3.54. I see.
Yes.
I'm sorry, I might have missed your presentation somewhere about the alginate without impregnating with ionic liquid. How is the performance?
It's a bit low. It's a bit low compared to, but I'm not sure. I'm not sure whether I put in the paper or not. The percentage without the ionic liquid. I think I don't.
I see.
I think nothing. But the result is doing that while doing the experiment. Of course, that one is the baseline, so I have to conduct the baseline. So
Okay.
so based
Okay.
on the baseline, yeah, a little bit compared to with ionic liquid. Of course, the ionic liquid will give a higher extraction efficiency.
Yeah, understood.
If I'm
Okay.
not mistake, maybe like 40 or 40 to 50% only compared to with ionic liquid.
Okay. Okay. Thank you, Dr. Noor Ain,
Thank you.
for the interesting discussion on your research work related to extraction of metal ions from wastewater. Nice knowing you. Thank you.
Thank you, Doctor.
So our next presenter is Mrs. Noor Hafiza Barahim. She is from University Technology Petronas and Petronas Research Sendirian Berhad PRSB, with her topic on effects of metal ratio and promoter on physical chemical properties of copper ion catalyst. The floor is yours, Mrs. Noor Hafiza.
Assalamualaikum and good day to everyone. My name is Noor Hafizah binti Ibrahim. I'm from University Technology Petronas. The title of my presentation for today is Effects of Metal Ratio and Promoter on Physico-Chemical Properties of Copper Ion Catalyst. Let's start with the introduction. The rapid development and industrialization increases an income per capita, and the opportunity provided with an increase in income further enhances the energy demand at individual as well as at the sector level. This resulted in an increase in greenhouse gas emission. The increase in greenhouse gas emission resulted in a climate change which caused direct or indirect effects such as an extreme heat, increasing allergens, and ocean acidification, leading to hazards to human health. Carbon dioxide, which contributed more than 60% to the climate change, can be used as a feedstock in hydrogenation process. CO2 hydrogenation is a promising way in making waste to wealth and at the same time solve the environmental and energy issues. How does CO2 hydrogenation work? This figure shows a schematic diagram of a reaction network for the formation of carbon monoxide, methane, methanol, and ethanol during the hydrogenation of CO2. In the first step, carbon dioxide adsorbed on the catalyst surface via reverse water gas shift reaction to form an adsorbed CO. This adsorbed CO undergoes the successive insertion of hydrogen to form an adsorbed methyl and also an adsorbed acyl groups. The hydrogenation of adsorbed methyl will form methane, while the adsorbed acyl undergoes dehydrogenation, which leads to ethanol formation. The adsorbed CO can also undergo the successive insertion of hydrogen to form methanol. The objective of this study are to synthesize and characterize copper ion catalysts on alumina support to investigate the effects of potassium promoter on the physico-chemical properties and catalytic performance in CO2 hydrogenation. Let's proceed with the methodology. The unpromoted and promoted catalyst with fixed metal loading of copper ion and with the copper to iron ratio varies at 50-50 and 85-15 and with fixed promoter loading at 1 weight% were synthesized using wet impregnation method onto the alumina support. The samples were then stirred for 24 hours. The samples were then filtered and washed using deionized water. The paste that has been formed were dried in an oven at 120 degrees Celsius for 12 hours, and the samples were then calcined at 350 degrees Celsius for 4 hours. The synthesized catalysts were characterized using PSEM index to determine the morphology and elemental composition, N2 adsorption-desorption for textural properties analysis, H2TPR to determine catalyst reduction temperature, and CO2-TPD for basicity study. The catalysts were evaluated in CO2 hydrogenation reaction using microactivity fixed bed reactor. The catalysts were reduced in hydrogen at 250 degrees Celsius for 2 hours prior to the reaction. The reaction performed at 250 degrees Celsius at 20 bar with H2CO2 ratio of 3:1. The products were analyzed using an online GC at 30 minutes intervals. Let's proceed with the results and discussion. This slide shows the PSEM micrograph at 1000 magnification and the EDX mapping. All the catalyst samples exhibited an irregular morphology, and the metal oxide loading were uniformly distributed onto the catalyst support. The addition of 1 weight% of potassium promoter to the copper iron 50-50 and copper iron 85-15 did not give any significant difference in terms of morphology and elemental composition. This table shows the elemental composition by the EDX analysis. As you can see from this table, all the elements were present in all the catalyst samples. This slide shows the textural properties of the synthesized catalyst. BET surface area, pore volume of the alumina base support decreased after the metal oxide loading. This suggested that the metal oxide particles had successfully occupied the catalyst pores. The H2TPR profiles show that there were two distinct reduction temperature peaks at the lower region and also at the higher region site. At the lower region site, which assigned to the alpha and beta peaks occurred at a temperature in between 120 to 300 degrees Celsius associated to the reduction of highly dispersed copper oxide and the reduction of bulk copper oxide. While for the higher region site, which assigned to the gamma peaks occurred at a temperature more than 340 degrees Celsius, which associated to the reduction of iron oxide. And the catalyst with higher copper content at 85% shifted the reduction peak to the higher temperature site. The addition of potassium promoter to the copper iron 50-50 slightly improved the reducibility of the catalyst, whereby the alpha, beta, and gamma peak slightly shifted to the lower temperature site as compared to the unpromoted catalyst. The basic site of the catalyst were measured using CO2-TPD. These CO2-TPD profiles display the three different basic sites of the catalyst samples, whereby the weak basic site, which assigned to the alpha peaks, occurred at a temperature less than 300 degrees Celsius, while the moderate basic site, which occurred at a temperature in between 300 to 700 degrees Celsius, assigned to the beta peaks, while the strong basic site, which occurs at a temperature more than 700 degrees Celsius, assigned to the gamma peaks. In this work, the slightly acidic alumina has been used as a catalyst support. Since carbon dioxide is an acidic gas, the adsorption and dissociation of CO2 can be promoted by the basic site of these catalyst samples. The moderately basic site of the catalyst is actually associated to the metal oxygen pairs of copper oxide, iron oxide, and aluminium oxide, while the strong basic site is attributed to the coordinatedly unsaturated oxide ions existing from the partial breakup of the metal oxygen pairs. This slide shows the catalytic performance of the catalyst. And from this table, you can see that the equal ratio of copper ion at 50-50 resulted in higher CO2 conversion of 11% as compared to the high amount of copper content at 85%, which is only 6% of CO2 conversion. And the addition of potassium promoter to the copper ion 50-50 enhance both the CO2 conversion as well as alcohol selectivity, whereby the CO2 conversion increasing from 11% to 45%. For the conclusion, increasing the copper content did not change the catalyst morphology and shifted the reduction peak to the higher temperature. The presence of potassium promoter improved the reducibility of the copper ion catalyst and increase in the CO2 conversion. On behalf of the authors, I would like to thank you to YUTP Research Grant and MRA Research Grant for the financial support in this research. That's all from me. Thank you.
Thank you. Thank you, Mrs. Noor Hafiza.
Thank you, Dr. Chong.
Based on your words here, you have monitored also, you have managed to monitor the presence of carbon monoxide in the midst of methanol and ethanol.
Yes.
Right?
Yes, you are right.
Did you also monitor the content of hydrogen?
We are not measuring in terms of the hydrogen balance, but we are calculating in terms of the carbon balance of the reaction.
I see.
Yeah.
Because you might have some syngas being produced at the same time, although your feed, you do add hydrogen into your feed.
Yes, actually this reaction using the CO2 and H2 as a feed, yes, you might have a competing reaction which is the reverse water gas shift reaction. So in this case, we need to find the right operating condition in terms of the temperature, because as you know that the reverse water gas shift reaction is favored at the higher temperature side as compared to the CO2 direct hydrogenation. So the operating temperature, one thing need to be optimized in this case, and at the same time the right bimetallic catalyst also need to be using the right metal catalyst.
Okay. Thank you very much for your
Welcome.
interesting work on CO2 valorization. Yeah, thank you very much.
Welcome.
Have a nice day.
Thank you, Dr. Chong.
Thank you. Thank you. Our next presenter is Miss Nina Sakina from the Department of Fundamental and Applied Sciences and also Center of Research in Ionic Liquids, UTP. She will be presenting on the topic ultrasonication assisted extraction of lipids from Chlorella vulgaris with B-methyl sulfate as an additive.
Assalamualaikum. Hi ladies and gentlemen. My name is Nina Sakina binti Azman. Today I would like to present to you my research project titled Ultrasonication Assisted Extraction of Lipids from Chlorella vulgaris with B-methyl sulfate as an additive. This is the outline of my presentation. I will talk about the introduction, proceed with methodology, result and discussion, conclusion, and also reference. Introduction. Biodiesel. Why biodiesel become attention among researchers nowadays? This is because the global energy crisis is mounting day by day due to growing of populations, together with depletion of the non-renewable energy. Here, biodiesel as a green renewable resource will help in solving the arising issues. Basically, biodiesel is described as the monoalkyl ester of vegetable oils or animal fats. There are several advantages of biodiesel, such as non-toxic, biodegradable, renewable, and also can reduce level of pollutants and carcinogenic compounds. In the production of biodiesel, it is important to choose the right type of feedstock. Here, there are several types of feedstock, such as edible, non-edible oil, waste cooking oil, animal fats, and also microalgae. So here in this project, I choose microalgae as my feedstock in the production of biodiesels. What is microalgae? Microalgae are prokaryotic or eukaryotic photosynthetic microorganisms, usually less than 2 micrometer in diameter and unicellular. There are several types of microalgae such as Spirulina species, Cholera species, Donatella species, Proterococcus species, and also Haematococcus species. Here in this project, I choose Cholera species as my type of feedstock. There are several advantages of the microalgae such as rapid growth period, easy to cultivate, and also higher free fatty acid content. After choosing the feedstock, next step is the lipid extraction techniques. Here, lipid extraction techniques can be divided into two, which are mechanical and non-mechanical. Under mechanical, we have bead beating, ultrasonic, microwave, and stirring. Under ultrasonic, we have ultrasonic bath and also ultrasonic horn or probe. While non-mechanical, we have supercritical extraction, solid extraction, and solvent extraction. Comparison have been made between the ultrasonic and stirring method in the presence of solvent, which is ionic liquids. By using ultrasonication, three different effects were studied: effect of solvent, effect of ionic liquid loading, effect of time in the presence of ionic liquids. While by using stirring method, effect of temperature were studied in the presence of ionic liquids. Moving to the research methodology. Here is the cultivation of the Cholera vulgaris. First, BG11 medium were prepared in a 5 liters quadrant. Proceed with the addition of 10% of Cholera vulgaris stock in the medium. And then the medium were supplied with the air pump under fluorescent lamp for 22 days. Then 3 ml of algae were taken daily and went for UVVs to measure the growth rate. Next, the Cholera vulgaris were harvested and dried in the oven with temperature 55 degrees Celsius for 3 days. Then Cholera vulgaris were blended to small particles and saved for prior use. Next, extraction of lipids by using ultrasonication. 200 mg of Cholera vulgaris was weighted, and then 50 ml of methanol or water were added in the presence of ionic liquid from range 0.5% to 1.5%. Then proceed with ultrasonication in the various time, 10 minutes, 20, 30, 40, 50, and 60. And then hexane were added and went for centrifugation process. After that, hexane and lipids layer were collected and went for rotary evaporated. Lastly, lipids were weighted. Next is the extraction of lipids by using stirring method. 20 mg of Cholera vulgaris was weighted, then 5 ml of methanol were added in the presence of ionic liquid range from 0.5% to 1.5%. Then the solution was stirred in the 4 different temperature for 40 minutes. Then hexane were added and went for centrifugation process. Hexane and lipid layer were collected and went for rotary evaporator, then processed with the weighing of lipid. Moving to result and discussion. First, cultivation of Cholera vulgaris. Figure 1 shows the growth curve of the Cholera vulgaris. Based on the graph, day 1 until day 7 is known as the exponential phase. Day 8 until day 12 is known as the linear phase. Day 13 until day 18 is known as the stationary phase. Day 90, which is the highest chlorophyll number, is the harvest day for the Cholera vulgaris. Next is the effect of solvents in extraction of lipids by using ultrasonication method. Figure 2 shows the comparison between methanol and water in extraction of lipids by using ultrasonication. Based on the graph, you can see that methanol gives 8 higher times extraction of lipids compared to water. In the presence of ionic liquid, for the graph methanol, we can see that highest lipid extracted were achieved at 1.0% and then decrease at 1.5% and then start to plateau. Here, the presence of methanol helps in the disrupt of cytomembrane of the microalgae, while the presence of ionic liquids help in disrupt the structure of fiber binder in the cell wall, thus make the organic solvent easy to extract the lipid compared to water. Next is the effect of ionic liquid loading and temperature. Graph shows the extraction of lipids by using ultrasonication with bemethylmethyl sulfate at different time. Here we can see the interval of the ionic liquid loading were decreased to 0.2% based on the previous results. Here we can see increase in time lipid extraction also increased. From the graph, you can see that 1.25% of ionic liquid is the best ionic liquid loading for 3 different temperatures. However, highest lipid extracted were achieved at 40 minutes with 26.78% of lipids extracted. Based on the previous result, effect of time with ultrasonication and radiation with 1.25% bemethylmethyl sulfate was studied. From the graph, you can see that as the time increased, the total lipid will decrease. From the graph, the optimum time for the ultrasonication irradiation is at 40 minutes and then decrease at 50 and 60 minutes. This is because ultrasonication produces heat. When long exposure, the lipids tends to denature. Next is the extraction of lipids by using stirring method. Here, effect of temperature were studied at room temperature 30 degrees C, 40 degrees C, and also 50 degrees C. Based on the graph, you can see that for all temperature, highest lipids extracted were achieved at 1.25% of ionic liquid. However, with 1.25% of ionic liquid, 40 degrees C give highest lipids extracted. Conclusion. As a conclusion, we can say that the highest lipid extraction were achieved at 1.25% of ionic liquid loading for both methods. However, ultrasonication is more effective compared to stirring method. This is because ultrasonication able to extract lipids almost 3 times higher compared to stirring at room temperature, with 26.7% compared to stirring method 9.25%. Thank you.
Thank you very much, Nina. There's a question here about when you increase the content of ionic liquid after the maximum value, giving you the maximum extraction, that is 1.25%. If you were to increase the content of ionic liquid higher than that, can you explain why it gives you a decreased amount of extracted lipid?
Okay, based on my reading, when we increase the amount of ionic liquid, the solution become viscous, more viscous. That's why the lipid extracted lower.
I see. Okay, that's all. Thank you very much, Nina.
Thank you, Doctor.
Thank you for your discussion. Nice day.
Okay, thank you, Doctor. Thank you so much.
Our next presenter is Miss Shida Sabah Fatima. She's from High COE Center for Biofuel and Biochemical Research, Institute of Self-Sustainable Building, UTP. She will be presenting on a comparison of two methods for the development of low-cost carbonaceous adsorbent from rubber seed shell, RSS. The floor is yours, Miss Shida.
I'm Saida Sabah Fatma from University Technology Petronas, Malaysia. And the topic of my presentation today is development of carbonaceous adsorbent from rubber seed shell and used for CO2 capture. These are the contents of my presentation today. Here's an overview of CO2 capture. Over the years, carbon dioxide capture has become an active research topic. The major reason behind this is the huge release of gas into the atmosphere on daily basis from various sources as mentioned here. Such huge release of CO2 into atmosphere has caused serious environmental issues, including global warming and climate changes. Over the years, many techniques and processes has been developed to mitigate the issue. But adsorption is so far considered the most promising and most efficient method used for carbon dioxide capture. Among various choices of solid adsorbent, activated carbon has the advantage of widely available precursor and easy synthesis. KOH is the most common activating agent used for the production of activated carbon, but research shows it causes some environmental issues because of its corrosive nature. The main objective of this study is to use a mild activating agent like potassium carbonate as a replacement of KOH for the production of activated carbon using rubber seed shell, and then evaluating its performance towards CO2 capture. Here's an overview of the current technologies used for carbon dioxide capture, along with their pros and cons. Adsorption is the promising method because of the advantages mentioned here. It also eliminates the disadvantages associated with some of the most common technologies used, such as liquid-based absorption. Several adsorbents are available for carbon dioxide capture, but activated carbon is selected as the preferred choice in this study because of its widely available precursor, easy synthesis, and hydrophobic nature. Here, a comparison of different carbonaceous and non-carbonaceous adsorbent used for carbon dioxide capture is presented. Each of these adsorbents have some advantages and some disadvantages. Rubber seed shell is a promising source of biomass because of its abundant availability in Malaysia. This is because of large rubber plantation in the country. Rubber seed shell has high carbon content, is abundantly available, and has low cost, which makes it a suitable precursor for activated carbon production. Activated carbon can be synthesized via physical activation or chemical activation methods. In this study, chemical activation is selected as the preferred method for the production of activated carbon. AC samples are produced using two different methods of chemical activation, namely two-stage chemical activation and three-stage chemical activation. Both of these methods are compared on the basis of experimental findings to select the promising method for AC production. This is a schematic of chemical activation processes used for the production of activated carbon, including the one-stage, two-stage, and the three-stage activation methods. Pristine AC shows low CO2 adsorption properties. Research showed that CO2 adsorption of activated carbon can be improved by surface functionalization. Since CO2 is an acidic gas, treatment of activated carbon with proper basic group will eventually result in improved CO2 adsorption capacity of the material. This is the methodology used for the production of activated carbon samples in the current study. Now let's move to the experimental findings. In this study, activated carbon is produced by various combination of the operating parameters, including the carbonization temperature and impregnation ratio of the activating agent. Yield analysis is one of the tools which is used to evaluate the findings, thus finding the appropriate combination of operating conditions for the production of activated carbon. As evident from the results, overall the yield of process has decreased with an increase in carbonization temperature and an increase in impregnation ratio. Highest yield is obtained at a temperature of 500 degrees C with an impregnation ratio of 1:1. On the other hand, the carbon samples are expected to be richer in carbon as the temperature is increased, because at higher temperature, more volatile matter is evolved from the sample, leaving the remaining structure richer in carbon. The SEM images of raw rubber seed shell show uneven surface with nearly no pores. However, the presence of pores can be clearly seen in the activated sample prepared by two-step chemical activation and the one prepared by three-stage chemical activation. Activated carbon, which is produced by three-stage chemical activation, has a very fine and well-developed porosity. And this sample is expected to have higher surface area and thus higher CO2 adsorption properties than the one prepared by other method. This hypothesis is also supported by SAP analysis and the results of adsorption test. The elemental composition of raw and treated rubber seed shell was evaluated using an elemental analyzer. Raw rubber seed shell has a carbon content of more than 40%, making it a suitable precursor for activated carbon. The carbon content is significantly improved after carbonization for both activation methods. Overall, the chemical composition of AC prepared by two-step activation and three-step activation is more or less same, except the three-step activation results in higher nitrogen content. FTIR spectra of raw rubber seed shell and the treated sample were recorded, and the peaks were mapped using the literature to identify surface group present in the samples. Overall, the FTIR spectra of both samples is more or less same. However, the intensity of some peaks is reduced in the treated sample. This is because of some temperature sensitive groups are actually diminished after heat treatment. One of these groups is the OH stretch, which is caused by the hydroxyl group. This peak appeared near 3300 wavelength, and the intensity of this peak is reduced in the treated sample because of the removal of surface-mounted moisture during heat treatment and carbonization. Both the samples have characteristic peak of alkene, which corresponds to carbon double bond carbon stretch and occurs near 1600 wavelength. This is also the characteristic peak which acts as a backbone structure of carbon. The selected sample from both activation methods were evaluated for CO2 adsorption test. CO2 adsorption test was performed on high pressure volumetric analyzer at room temperature and atmospheric pressure. Since adsorption of CO2 is an exothermic nature, therefore low temperature is favorable for adsorption study. AC prepared by three-step chemical activation showed higher CO2 adsorption capacity among other samples. Adsorption results were also compared with other biomass precursors found in literature. The adsorption data is in agreement with the one which is reported in the literature, and the prepared material serves good adsorption properties. In conclusion, the surface modification of activated carbon is an effective technique to improve the surface capturing properties. AC samples prepared by three-step activation have better porosity and higher CO2 adsorption properties than the ones which are prepared by two-step chemical activation. Thus shows that three-step activation works better in the production of activated carbon. Potassium carbonate works very well as an activating agent and can be used in replacement of KOH, thus eliminating its harmful impacts. Rubber seed shell is successfully converted into activated carbon and shows good adsorption properties, which can later be used for a commercial adsorbent for CO2 studies. That's all from my side. Thank you so much for listening.
Thank you very much, Ishida.
Thank you.
There's one question here related to the yield. For the highest yield was displayed by the activated carbon synthesized from the two-stage process and calcite at 500 degrees Celsius. Do you think this criteria is an important one for your selection to produce a very good CO2 adsorbent material?
Actually, the yield plays a very important role when you are preparing the adsorbent in bulk quantity. Like if you get a very low yield, you will be using a very large quantity of the biomass. So in that case, it becomes an important parameter. But since it was just like on experimental basis, so uh, it is not that much important of a factor, but still it is countable, especially if the source of biomass is somewhat we say difficult to access, then the yield is an important factor. But in this case it was used as a tool just to evaluate which combination of the operating parameters will work best to obtain a good sample.
Another question is after you have conducted the adsorption process, the CO2 adsorption process, what will you be doing with the adsorbent? Will you be recycling it or will you just go for disposal?
No, it is in one of our objectives to study the repeated regeneration cycles, just to see that for how many cycles does the adsorbent hold the stability, or means it's regenerated after so many cycles, and how much of the original adsorption capacity is restored, let's say after 10 cycles or after 12 cycles. So it is one of the objectives to study the regeneration study of adsorbent material.
Thank you very much for your interesting work on rubber seed.
Thank you so much, Doctor.
Ida. Yes, nice day.
Have a good day.
Our last but not least, let us welcome Mr. Hassan Issa from the Federal University of Dotsinma, Katsina State, Nigeria, to present on post-remediation assessment of Tonga Guru artisanal gold mining village family houses. The floor is yours, Mr. Hassan. Mr. Hassan, you will need to share your screen.
You're taking us to. main stage here.
Yes.
I'm not supposed to be here.
Okay, give me 1 second.
I think you are going down. Which call this slide?
Somebody will present it on there.
Mr. Hassan, you're live now. Can you click on the share screen to present?
Yeah. Right. So we should share it.
It's the fifth button. Have the presentation, the camera, the mic settings, and share screen. Please click on the share screen. The floor is yours, Mr. Hassan.
HOD, please, we want you in Mala Dangado's office here. We are having a bit of difficulty, although there is network, but maybe you have to be around to look at one of the things. It's almost our turn. It's about our turn. In fact, they have already started showing us.
We have lost Mr. Hassan. I think Mr. Hassan is trying to log out and log in again.
Yeah, not desktop.
Hi, Mr. Hassan. Are you ready?
Hi.
Your
Hello, please,
sharing?
sorry, we are trying to carry out the sharing.
Ah,
Entire
do
screen.
at the bottom of the screen, do you see presentation, camera, mic,
Yeah.
the
At
icons?
the bottom, yeah, yeah.
Ah, the
Presentation, camera, mute
af-
setting, then
after setting, share screen.
yes, we've done
Ah,
all.
click on that.
We've clicked on it. We've clicked on it.
Click on share screen.
Yes, I've done that.
Then
Then we have entire screen window.
show your presentation. You need to display on your desktop your presentation slides.
Where is this slide?
It's on the desktop.
It's on the desktop.
Let me go back to desktop.
Do you minimize?
What do you see when you click on the share screen?
Yeah, it gave us the options of the, it display a window that has entire screen window, then Chrome tab.
Good.
Okay, all right.
I'm busy.
You click on the
Are you on
on the
then?
option for your desktop.
Ma?
Share your desktop.
That's exactly what we did. Entire screen. It gave us three options: entire screen, window, then Chrome tab.
Entire screen.
Entire screen.
Then
That's
you
exactly
show
what
your
entire screen.
presentation. Then you close this particular Icfas Studio. Minimize it. Don't close. Minimize the
Okay, so
Icfas
minimize it.
Studio and show your presentation slide. Then you can start presenting.
Okay. This is the presentation slides. Then you can start presenting.
Can you see the slide now?
Not yet.
Hello. Is the slide on with you now?
Hello?
Cannot see.
Can
Not yet.
Not yet. I think what we only there should be a upload the slides into the presentation. Share. Okay. Click here. And share.
Yes. Can you show your slide? You minimize this particular screen, then you show your presentation slide.
Okay, let's do that. Can you see the presentation slides?
Yes.
All right.
Yes, very good. You can start presenting
Right.
now. Thank you.
Top of the how I mean the members. My name is Grigis Show, second team member in this research group. I'm here on to present our work on post-remediation assessment of Tungaguru Artisanal Gold Mining Village Family Houses, Zamfara State, Nigeria. Where is the click on? Okay.
You can have slideshow.
Good. Now, can you see this? Can you see the slide?
Yes, yes.
Good. Within the years 2010 to 2013, integrated health and environmental response addressed an epidemic lead poisoning in Zamfara State, Nigeria. This is due to artisanal gold mining contamination. We can see the study area there, and this, that's a picture of the study area. Then the sampling. Soil samples were taken from family houses at random and pulverized into fine powder. So this is now taken to EDXRF spectrometer for analysis. The irradiation of the samples were performed by assigning time-based program controlled by a software package provided with the system. The X-ray intensities of the element in sample spectrum, which determines the concentration, was calculated using system software. The outcome of the analysis give us result which we will see the table very soon. But we have indices. The contamination factor, which you can see there, and the second one is index, which you can also see there. So this is the geochemical result from the based on that geochemical result, we can see that the metals, you can see that in that order is which is well above the background. Then this is the pollution. If you can have a look at the pollution analysis critically, you will be able to see that the lead and arsenic and mercury in very high concentration from that table. It can be seen from the table. Lead on the fifth line there can be seen, arsenic and mercury. So we're able to in the analysis that those items that are of interest health-wise are wolframite, arsenic, and lead, and all of them are at very high concentrations above the background. Assessment. So we can see the outcome here. We can see the mercury, arsenic, and lead also well raised. From the studied metals, the highest value of IGO were found to be lead 2.035 and arsenic 2.63, which is indicative of moderate soil pollution. Particularly for lead, which is at any concentration is toxic. Mercury value at soil indicative of active presence of gold or in many family compounds. This means that villagers actively take home the ores for sales. Conclusion. This implies that the post-remediation assessment conducted revealed that the villagers have abused the remediation processes. Largely, those are ignorance, recalcitrant nature of some of the villagers, mining exercises, as main activities, as well as lack of total submission to the laid down post-remediation regulations. Recommendations. Health authorities need to embark on regular reorientation on hazards of mining. Some notable features of reorientation themes include Roman figure 1, avoidance of breaking, wasting, washing, drying, or storing ore or material in or near home compound. Second, avoidance of using the ground for mining activities for making bricks or walls for home. Third, children should not be allowed to play in formal. They should wash their hands with soap and water before eating. Second major point there is the community leaders need to establish a team to identify recalcitrant violators, to have them brought to book to serve as deterrent to others. This can be taken up at community levels to further clean up the family compounds by self-help projects of villagers to ensure from future potential hazards of mining. These are the references.
Thank you, Mr. Hassan.
Yeah.
The it is a work that you look into for reclamation of the gold mine. Am I correct? This work,
Yeah,
reclamation of their gold mine, and it seems
yeah.
that there are a very high content of mercury in there. Is
Yes,
there
it is
any way?
found in the veins on the mining. Mercury and lead substantially found inside.
So are there any families staying there at the moment?
These mining areas have farming villages around. And you know, when you have to deal with local people who doesn't have much to do with mining, both adult and children, that's their pastime in Nigeria. In fact, in most of the African villages. So there are many villages around mining locations. So most of these miners are essentially farmers who are having less to do during the dry season.
I can see. So because lead and mercury, those are very toxic
In fact,
metals. Yes.
lead at any concentration is very toxic. Any low concentration.
So have you also looked into the population, especially children, on whether they have been affected on these toxic metals to their
Yes.
health?
You
Yes.
see, the focus of this work was that there was actually a large volume of contamination recorded because many children were found dying, stomach troubles. Then health authorities, including Doctors Without Borders,
I see.
Doctors Without Borders came there and they did assessment. Then they conclude it was the poisoning was from lead veins.
Okay. Okay.
Yeah,
It's this is a very interesting work on this
yeah,
post remediation. So I
yeah.
give you my best wishes to continue with this noble work. Yeah, on
Exactly.
remediation to help these children and then the villagers also from these toxic poison metals. Yeah, thank
Thank you
you
very
very
much.
much, Mr. Hassan. So
Yeah,
I guess that's the end of the session. Uh, so thank you very much, Mr. Hassan, for the interesting
you are welcome,
discussion.
please.
Yeah,
Yeah, you are welcome.
yeah.
Thank you very
We-
much.
Thank you. We have come to the end of this session. On behalf of Icfas 2020, thank you to all presenters and audience. Have a nice evening and keep safe.
Okay.
Thank you.
We've done it.
Nice meeting you. Dr. Cairo, I will leave, yeah? We have completed.